Okay, so this is going to be a video that's going to go over 3.4, which is sum and difference identities. And then we also have a multiplication, a double identity, and a half identity. Okay, so double angle, half angle is what it's called. So you're going to have access to all of these formulas, but we're going to go through sort of how to use them is what we're going to focus on, not necessarily the proving of them. So if we go through this then, all right, here are the formulas that you are going to have access to. So the first one is, right, if I have a sum within a sign, so alpha plus beta if you want, there's a pattern that sets up here if you see it, okay? Now you have to keep track of these little elements here. And again, you won't have to memorize these, but we'd like you to be familiar. So when it's a plus here for sine, right, it's going to be sine of the first one plus cosine, or times cosine of the second one, plus, this plus matches is another thing that comes up there, okay? It's going to be cosine of the first one, sine of the second one. All right, we'll do an example of that. Now, if you notice over here, for the sign of a difference, okay, it's pretty much the same, all right? The only thing I want to point out here is when this is a minus, this is a minus. The rest of it's the same. So if we sort of ask you to memorize some of that, internalize some of that, that's how that one works. And notice that it goes sine, cosine, cosine, sine, all right? Now down here, when we look at cosine of a sum, so again, for here, what we're looking at is we're looking at alpha plus beta there, okay? And one of the things here, if you notice this one, is it's cosine, cosine, sine, sine, if we ask you to look at it. The other thing is, if you look at the sign here, this changes, it flips. So again, you'll have access to this. If you're internalizing it, that's how we would ask that you memorize it. Similar over here, what you'll notice is this is a minus, this is a plus, so it just flips around kind of, right? But still cosine, cosine, sine, sine is how that one works. I'm going to leave tangent out of this video, and we're just going to focus on sine and cosine. So it says, what patterns should you recognize? All right, so we kind of went over that, right? Sine keeps the sign. Two different signs there, right? So sine keeps the sign. All right. The other thing is, right, sine alternates. If that's a word you're familiar with, right? Which means I use one and the other. And cosine, yeah, sort of grouped, I guess, is a word we could use. Right? Which means like it goes cosine, cosine, sine, sine. All right. Again, you'll have access to those, but we can look at it. So let's look down here and see if we can expand some of these. So for example number 1 here, it says find the exact value of this. Now, if we do this backwards, here's why we have this one, right? 70 and 40 are not two of our main, what do I say? Two of our known quantities, right? So it's not a 30, 60, 90. But guess what? If I undo that and we relate that to up here, which one of those matches up here? I think for this one, for number 1, I think it's this one. Can you see it there? I got a plus in between. Now watch what happens then if I undo that. If I recognize that pattern, this can be rewritten as the cosine of 70 minus 40. And now all of a sudden, I'm evaluating the cosine of 30. All right, so do you see the strength in that a little bit? We're going to do the reverse of that. So what's the cosine of 30? I don't know if you remember. Let me set it up here, right? 30 is my reference angle. Cosine's this length. That makes it the long length. I don't know if you're with me. I'm hoping if I wrote positive root 3 over 2 here, that's something you can recognize. Okay? I don't know. Kind of interesting, I guess. So let's look at example 2. All right? How about this one? All right? What do you notice here for just part A? I have sine of 22, cosine of 13. Right there. So for that one, again, I don't have anything that goes with that necessarily, but if I was to rewrite that and match it up, okay, which one does that go? It's an alternating pattern, right, with a plus in between. So if you go up here, the alternating pattern with a plus in between, I think, I'm sorry, is this one. So what could we do? We could rewrite that, if I would have it, as the sine of 22 plus 13. Now this doesn't help me too much, but what you would evaluate then is the sine of 35 degrees if I'm just rewriting it. Okay, so not quite as good a result as that, where I know my answer, okay? All right, now, let's look here and see. This is where it really comes into play in my mind, okay? Is that what this pattern allows you to do is find the cosine or sine of an angle that I'm not familiar with using two angles that I am familiar with, okay? And this is a great example of, if I ask you to find the exact answer for cosine of 15, you're like, I don't know it. But guess what I can think of? You know what? Two of my knowns are 45 and 30, and if I would subtract them, I would get 15. Okay? I don't know, you're probably not following this as closely, but the other thing I could use 60 and 45, right? 60 and 45 are two that I know, and if I subtract them, I would get 15. But this is just as well. So once I identify that, I can write that and come up with knowns. So if I was going to do the cosine of a difference, I don't know, you probably haven't internalized this yet, but cosine, they stay the same. So it's going to be cosine of 45 times cosine of 30, if you're tracking that. Now, if you remember here, what happens to the sign changes. So when that's a minus, this is a plus. And again, you'll have access to that formula. And then it's sine. It's kind of how we would ask you to memorize it if we were going to. Now, what's kind of interesting about this is that I know all of these, right? So now I've taken an angle that I don't know, put it into two knowns. Do you remember cosine of 45? Hopefully root 2 over 2 rings a bell. Cosine of 30, root 3 over 2. Sine of 45, root 2 over 2. And sine of 30, 1/2. Okay? I don't know. So I don't know if you remember, this right here would give me root 6 over 2 plus root 2 over 2. Oh, no, root 2 over 4. Sorry, these are 4s. My bad. Root 6 over 4, because we multiply the denominator, of course, over this over 4. So then there's a couple of different ways to put this together. I mean, you could leave it like that, or, because I have a common denominator, we could write it like this. Either one. But what that does is give me the exact answer to an angle that's not common by subtracting or adding common numbers, okay? So that's what I'm going to leave that one with, all right? So now we're going to scoot down here. I'm going to skip all that to this one. So for the double angle formulas here then, okay, there are ways that we can look at, instead of adding and subtracting, what we can do is we can double the angle or we can half the angle. All right, now again, these we're not going to ask you to memorize. It's almost like a pairing exercise, and we're going to ask you to focus on the sines and the cosines, okay? And we choose different ones. Now, in certain college classes, the double angle for cosine becomes a little more problematic because there are 3 different choices, right? Down at the bottom for the half angle, there's just one, and for the sine, there's just one, okay? So we'll kind of stick with those if we are. Now, we're not going to go through proving them because I think you believe me, probably, right? So we're not going to do those. But let's go down here and do example 3. Okay, so if I gave you this one, and it says, given the triangle that right, find each of the following, okay? And then we'll try to apply another one to the half angle. We're just going to focus on sine and cosine here, okay? So if we're doing that, here's my triangle. Given the right triangle with the right, find what you know. So the first thing I need for this, and again, we didn't focus on the formulas very much, but I am going to need the hypotenuse here because I'm going to have to write quantities for sine and cosine. So how do we do that again? Pythagorean theorem. 4 squared, 16. 1 squared, 1. We leave it as a radical. Everybody agrees square root of 17 is what that would be. Okay, so square root 4 squared plus 1 squared. Okay, now, once I have that, let's look at sine of 2 theta. So I got to scroll back up here, okay, and I'm going to use this one right here. So the way I can do it then is, right, because you can't mess with this, which you'll learn later on, right? The argument of a trig function can never, ever change. So my only hope is to break it down so I can utilize it and get rid of the 2 on the inside. In this case, it becomes a 2 on the outside by property. So if I use that one, what this one becomes is I can rewrite this as 2, okay, 2 times sine of theta cosine theta is how that property or that postulate works. All right, then I can kind of do it, right? So I'd have 2. What is sine of theta? Sine is opposite over hypotenuse. So this would be 1 over root 17. And then cosine would be adjacent over hypotenuse would be 4 over root 17. Now if you multiply that together, I don't know if you can see it or not, 2 times 1 times 4 gives me 8. And then what's kind of nice about this is root 17 times root 17 just gives me that. So that would allow me to get the value of sort of double the angle, all right, which does show up, again, we talked about in class, show up in some solving of some physics problems. How about cosine? Now, cosine, I have a choice, okay, of 3 of them, cosine of 2 theta. So if we come up here, all of these will work, all right. I guess if you can, we're going to utilize this one first, but I could use any one I want for it, okay? So if I utilize that one, right, I can rewrite it. And again, notice what happens here. I'm able to take that 2, which is problematic, and sort of eliminate it here, because I don't want to do it. And remember that that 2 up there means that they are squared. Okay, so let's do it. So for this one, I can rewrite this as cosine squared theta minus sine squared theta, and again, you'll have access to it. You just got to pair up the property like a matching exercise. So what happens here? What is cosine? Cosine again is 4 over root 17 from the picture, and I'm going to square it. That's what that means. Minus 1 over root 17, and I'm going to square it. Again, if you're following this sort of math-wise, squaring these with a radical is kind of a winner, because what do I get here? I square the top, and I square the bottom. It just becomes 17. I square the top, square the bottom, subtract, I get 15/17 for that. Okay, so that is a way to rewrite and find sort of a double angle related to that. Okay, all right, let's look at half angles here then. Okay, so what it says is, given that u over 2 equals 165, which means, by the way, can you see if I multiply both sides by 2, okay, this 2 will cancel. It does tell me that u is equal to 330, because I'll need that too, if that makes sense. Okay, so what this one means here then is, let's see if we can do it. So for sine of u over 2, go back up here to our list. Okay, I have this one right here. Okay, so again, if you had this in front of you, this is what you look for. It's a plus or minus square root, which means it's going to give you kind of 2 different answers. We'll talk about that, but we're looking at that to put it together. Let's see what we got. So for that one, sine of u over 2, okay, this can be rewritten then as the square root, okay, there's a half, okay, inside. So they move the half inside there, okay, and where that half comes from is here, is the way they're doing. All right, but if we split it up, so if I do that part, then it becomes that minus cosine of u over 2. Okay, so if you put that together, let's see here, 1/2, I could have 1 minus cosine of u. Now cosine of u, remember, is 330 because we found it. Okay, as far as that goes. Now, what's nice about that for this one, the way it works out, is this turns out then to be 1/2, and again, I sort of took the divided by 2 and made it that way. I don't know if you remember, 1 minus 330, right, is all the way around here. It's 30 short. So if you remember the cosine of that long side there, if you want, it's going to be root 3 over 2. So you could use your circle chart to get that. All right, if I do some other reduction here then, okay, depending on how you want to go through it. If I would have the square root here then of, well, my pen, right, there we go. So if I have this, right, square root, you could multiply through here a little. I would get 1/2 minus root 3 over 4. Okay, there's a couple different ways to simplify this a little bit. If I could get a common denominator, everybody agree that I could rewrite this as 2/4. Anything that helps me out with a little bit is if I rewrite that as 2/4, do you see I get 2 root 3 over 4? So the only thing that I could do that helps me out here then is, I don't know if you remember, whenever you have a square root or a radical over a thing, you can leave that with the numerator, but you can also find the square root of the denominator. In math world, it's a little better to write it like this. Kind of unnecessary. That's how that one goes together. okay? Let's see if we can do that one more time here with this one, okay? So cosine of u over 2, okay, is here. So if we have that one, what we're going to look at here is rewriting that. So it's 1 plus u over 2 on the inside. So this time, let me leave it like that. A lot of times it's easier if you pull the 1/2 out in the front, but let me just use that one for this one. So if I have the square root here, okay, again, if I was to rewrite that, it would be 1 plus cosine of u over 2. So this might be easier just to do it this way. Okay, so what would this be? It would be the square root of 1 plus cosine of 330, right, over 2. This just gets a little uglier here, right? So what does 330, cosine of 330, right? Same thing all the way around. It would be the same, I guess I erased my picture down here, right? So 330 all the way around. The cosine for that, again, would still be root 3 over 2. So for this one, it just gets a little uglier. 1 plus root 3 over 2 over 2. And this square root still comes down and captures all that. Okay, let me hop over here then. So if I have that, one thing I could do is I could divide both sides by a half, multiply top and bottom by a half to get rid of the denominator, okay, because that is really an answer. But if I multiply the bottom by a half and the top by a half, okay, I don't know if you can see, these two would go away. And what I'd end up with is, I would end up with 1/2 plus root 3 over 4, the square root of that. Okay, that is an answer that's a little cleaner. If you can picture this again, I'll change color so you can track me here. One way we could simplify this is you could make it 2/4. And again, in math world, that would give me, again, 2 plus root 3 over 4. And again, kind of weird, but in math world, having this on top over that is a little bit better. Okay, so again, we're trying to match formulas. You can either do it like this and bring the 1/2 out in front, or like this, it kind of works out. The simplification here will work through, but we would like you to get to here, I guess, and get this substitution and so on. So, all right, so we'll talk through that more.